Hello, I'll be talking about how to interpret co-immunoprecipitation and how it works. So basically, this procedure uses two types of antigen. The first antigen is to pull out the protein. The second antigen is to allow us to see on Western blot. So, for example, I have a solution containing protein A. And if I want to pull out this protein, I would use a bead. It contains an antigen that's specific to A. So when I put it in, this antigen will bind to protein A. And then later on when I centrifuge it, because the bead has weight, and that weight will pull the protein and the antigen down, and it will concentrate it in a pellet. So later on when I pull out this pellet, I will pull out the antigen, and I can just simply separate the antigen from the protein, and then I will just get a purified protein. Let's say, what if I add in protein B? And if protein B interact with protein A, then it will bind here. And later on when I centrifuge it and then get this thing out, I will also get protein B along with it. And then later on, technically, I will get protein A and protein B in a purified form. However, I have to check with Western blot, and that's when the second antigen come in. So before I go there, I want to quickly explain. So we are checking if GPCR protein interact with G-alpha in presence of hormone. Yes, in presence of hormone, the GPCR receptor also does bind and interact with the G-alpha subunit. And then later on, we also want to check if RTK receptor binds to RAS in presence of hormone. So as you can see, in presence of hormone, it doesn't directly binds to RAS. So if you pull out the beads and then if it pull out RAS, it will not pull along the RTK receptor with it. And this is the Western blot, so we're gonna check this one. So remember that all of them we use same second antigen, and this second antigen is specific to only GPCR. So the for this lane, the first antigen pull GPCR. So when I pull out GPCR, you have a presence of GPCR, and then later on when you put on second antigen, it will amplify as a band. This will act as a control. It's just a positive control for us to compare. And then later on, we also have the negative control, which is when we don't use the first antigen, so it will pull out nothing. And later on, when you use second antigen, there's nothing to bind there, so you would not see anything. It's just like a negative control for us to compare. And here's the thing that we're interested in. For these two lanes, the first antigen pull only the G-alpha. So the first antigen pull out the G-alpha. In presence of hormone, it also pull out GPCR with it. Because recall back, in presence of hormone, GPCR interact with the G-alpha. So that's why there is presence of GPCR. And later on, when you add second antigen in, there's GPCR. And here we go, we have a band. However, when there is no presence of hormone, G-alpha doesn't interact with GPCR. They stay separated like this. So that's why you do not see any band, because there's no GPCR. It never came out with G-alpha. So the beads would just G-alpha here and then GPCR seal in the jar. So that's it. We're moving on to the RTK. Again, positive control, negative control. So the positive control here contains the first antigen that pull out RTK receptor. And then for all of them, second antigen specific to RTK. So here the first antigen pull out RTK receptor, and because there is RTK, the second antigen can bind in and amplify as a band. Then later on, again, same technique, same concept. There's no antigens to pull out the RTK receptor, so there will be nothing for the RTK receptor to bind in, so you don't see any band. For these one, the first antigen pull out RAS, and because even with present or absent of hormone, the RAS doesn't pull out RTK receptor with it, so the RTK receptor will just stay in the jar forever, and that's why you don't see any band here. So to recap, there are two antigen used. The first antigen is to pull the protein out. Second antigen is to check if the partner protein came out with it or not. I hope that makes sense.